Topic is infinite series, and what I yesterday proved, I tell you in brief, that is called comparison test. Comparison test, you can take that as 1. What does test says? If sigma a and sigma pn are two positive term series, and an less than or equal to bn for all n greater than k, then if sigma bn converges, then sigma an also converges. Say this is first test, that is comparison test 1. Both are positive term series. Now the topic is positive term series. An less than or equal to bn. This is important. An less than or equal to bn for all n greater than k. Sigma bn converges, then sigma an also converges. Second is, if an greater than or equal to bn and sigma bn, an greater than or equal to bn for all n greater than k, sigma bn diverges, then sigma an also diverges. Tests are simple, and I have already proved this one, and you should get mastery over these two tests. They are very important while solving problems, and also from an examination point of view, these proofs may be asked. This is called first comparison test. Now today's topic is the auxiliary series. Auxiliary series, or it is also called P series or P series test. The test is like this: the sigma 1 upon n raised to p converges if p greater than 1 and diverges if p less than or equal to 1. This is very important tool, it is very important test, because throughout this topic up to the end of this topic, infinite series, we use this one. Therefore, it is very important. Proof, I explain first proof of this one, then practice second comparison test 2, then I explain how the comparison test 2 and this P series test can be used to solve the problems. Now test is like this: sigma 1 upon n raised to p converges if p greater than 1, diverges if p less than or equal to 1. This is called auxiliary series or P series test. Now proof of this one. First I take case 1, that is p greater than 1. Since it is a positive term series, sigma 1 upon n raised to p is a positive term series, we can group the terms of the series as we like, as we wish. Say, what is sigma 1 upon n raised to p? 1 plus 1 upon 2 raised to p, 1 upon 3 raised to p, 1 upon 4 raised to p, 5 raised to p, so on, etc. Up to infinity, because series means number of terms are infinite. Now we group that series of the terms like this: 1 plus 1 upon 2 raised to p plus 1 upon 3 raised to p plus 4 raised to p, 5 raised to p, 6 raised to p, 6 raised to p, 7 raised to p plus, next we take 1 upon 8 raised to p, 9 raised to p, 10, 11 plus 12 plus 13, 14 plus 15 raised to p plus 1 upon 16 raised to p, and so on and so on. Say, this is important. We group the terms of the series as we like, because it is a positive term series and p is greater than 1 here. Positive term series. Now see here, you know that 3 greater than 3 greater than 2, therefore 1 upon 3 is less than 1 upon 2, 1 upon 3 raised to p is less than 1 upon 2 raised to p because p is greater than 1. First understand this one. 1 upon 3 raised to p is less than 1 upon 2 raised to p because p greater than 1. Therefore, it is less than 1 plus 1 upon 2 raised to p plus 1 upon 2 raised to p plus. Similarly, this 1 upon 4 raised to p, 1 upon 5 raised to p, this 1 upon 5 raised to p is less than 1 upon 4 raised to p because here 1 upon 5 is less than 1 upon 4. Agree with this? 1 upon 5 is less than 1 upon 4 because 5 is greater than 4. 1 upon 5 is less than 1 upon 4. 1 upon 5 raised to p is less than 1 upon 4 raised to p. Similarly, 1 upon 6 raised to p is also less than 1 upon 4 raised to p. So I write this as less than 1 upon 4 raised to p, 4 raised to p plus 4 raised to p plus 4 raised to p. 4 terms are there. Plus, next similarly it is less than 8 raised to p, 8 raised to p plus so on plus 1 upon 8 raised to p plus so on. Similarly, next group is less than 1 upon 16 raised to p, 16 raised to p and so on. Now, this is first step here. So we have rearranged the terms like this, and this 1 upon 2 raised to p, 1 upon 3 raised to p is less than 1 upon 2 raised to p plus 1 upon 2 raised to p. This is less than 1 upon 4 raised to p, 4 raised to p, so on. Therefore, sigma 1 upon n raised to p is less than 1 plus, say, 2 by 2 raised to p plus 4 by 4 raised to p, 8 by 8 raised to p plus so on. Now, the right hand side series is a geometric series. See, in the beginning of the topic we have established the convergence of geometric series. Sigma r raised to n minus 1 converges if mod r is less than 1. R is less than 1, greater than minus 1, this series converges. Now, right hand side is a geometric series with r common ratio as r. What is r here? What is the common ratio? It is 2 by 2 raised to p, or it is 1 upon 2 raised to p minus 1. It is less than 1. Can anybody why it is less than 1? Because see, p is greater than 1. See, first case is p greater than 1. P minus 1 is positive. So 1 upon 2 raised to some positive means it is in the denominator and less than 1. Now therefore, this right hand side series converges. Now see the previous comparison test. What does comparison test says? If sigma an, sigma bn are two positive term series and an less than or equal to bn for all n greater than k, then if sigma bn converges, sigma n also converges. Now the right hand side series converges here. Bn is right hand side series. Right hand side series converges. Therefore, the left hand side series 1 upon n raised to p converges if p greater than 1. This is the first case. I think all of you followed the first case. Now, second case is let p is less than 1. Or second case is p is equal to 1. Take p is equal to 1. Say when p greater than 1 converges, p less than or equal to 1 it diverges. I prove why it diverges. P is equal to 1, then sigma 1 upon n raised to p is 1 plus 1 upon 2, 1 upon 3, 1 upon 4 plus 1 upon 5 plus so on. Because p is 1 here. 1 upon 1 raised to 1, 1 upon 2 raised to 1, 3 raised to 1 and so on. Sigma 1 upon n raised to p is this when p is equal to 1. Now we rearrange the terms like this. It is 1 plus 1 upon 2 plus 1 upon 3 plus 1 upon 4 plus 1 upon 5 plus 1 upon 6 plus 1 upon 7 plus 1 upon 8 plus so on. We rearrange the terms like this now. 1 plus 1 upon 2, 1 upon 3 plus 1 upon 4 and so on. Again this 3 is less than 4, so 1 upon 3 is greater than 1 upon 4. See here, 1 upon 3 is greater than 1 upon 4. Similarly, 1 upon 5 is greater than 1 upon 8, 1 upon 6 is greater than 1 upon 8, 1 upon 7 is greater than 1 upon 8. So we write it is greater than 1 plus 1 by 2 plus 1 by 4 plus 1 by 4 plus 1 by 8 plus 1 by 8 plus 1 by 8 plus 1 by 8 plus so on. Important, how to group the terms of the series is important. We have taken like this: 1 by 3 is greater than 1 by 4. Therefore, this bracket we can write greater than 1 by 4 plus 1 by 4. Here, all are greater than 1 by 8. 1 by 8 greater than 1 by 8 greater than 1 by 8. So, this is equal to 1 plus 1 by 2. 1 by 4 plus 1 by 4 is 1 by 2. And you add this, it is 4 by 8. 1 by 8, 1 by 8, 1 by 8, 1 by 8. 4 by 8 is 1 by 2. Plus next group is also becomes 1 by 2 and so on. So when P is equal to 1, P is equal to 1, sigma 1 by n raised to P is sigma 1 by n raised to P is it is greater than 1 plus say 1 by 2, 1 by 2, 1 by 2, 1 by 2, etc. 1 by 2, 1 by 2 plus 1 by 2, 1 by 2, so on. Now, see the right hand side series, so I prove that right hand side series diverges. Right hand side series diverges, then left hand side also diverges. Now for that, suppose Sn be the sequence of partial sums. Sequence of partial sums. Sn be the sequence of partial sums of right hand side series. Then Sn is 1 plus 1 by 2 plus 1 by 2 plus etc. 1 by 2. 1 plus, how many 1 by 2 are there? Because Sn means we take first n terms. You have studied that series by definition. When do you say that series converges? If the sequence of partial sums converges, then series converges. What is the sequence of partial sums here? Sequence of partial sums means we form a sequence by taking first n terms, sum of first n terms, 1 plus 1 by 2 etc. How many 1 by 2 are there here? Already 1 is there. Total number of terms is n. So n minus 1, 1 by 2 are there. Therefore it is 1 plus n by 2 minus 1 by 2. So n plus 1 by 2. N by 2. 1 minus half is half. So n plus 1 by 2. What is this? This is the sequence of partial sums Sn is given by this. Nth term is n plus 1 by 2. Now limit Sn as n tends to infinity is infinity, because n tends to infinity, this becomes infinity. Now therefore what does this implies? The sequence of partial sums Sn diverges. This implies this right hand side series diverges. Therefore by comparison test the left hand side also diverges. Sigma 1 upon n raised to P diverges. What is the case? P is 1. See the proof important. Repeatedly I am telling you this examination, the proof may be asked. One more case is left. What is that? Case 3 is P is less than 1. P is less than 1. Third case. Now in this case, sigma 1 upon n raised to P is 1 plus 1 by 1 raised to P, 2 raised to P. P is less than 1 here. 3 raised to P, 4 raised to P, plus etc. We now group the terms of the series like this. We group the terms of the series like this. or since p is less than 1, it is greater than 1 plus, say p is less than 1, therefore what happens here, p is less than 1 upon n raised to p is greater than 1 upon n, correct? 1 upon n. So here, since p is less than 1 upon n raised to p is greater than 1 for all n is equal to 2, 3, 4 and so on. 2, 3, 4 so on. 1 upon n raised to p is greater than 1 upon n because p is less than 1 here. Less than 1. You can take here 1 upon, can I give any example here? Say 4, correct? 1 upon 4 raised to p is greater than 1 upon 4. Greater than 1 upon 4. I take one case here. 1 upon 4 raised to p is greater than 1 upon 4 because p is less than 1. P is less than 1 means I take half. P is half. Then what happens? 1 upon 4 raised to half is greater than 1 upon 4. I explain this one because it is true here. Because 1 upon 2 greater than 1 upon 4. Correct? 1 upon 2 greater than 1 upon 4. See, therefore, if p less than 1 upon n raised to p is greater than 1 upon 4, 1 upon n, this is where plays very important role in the proof. For all n is equal to 2, 3, 4, etc. Therefore, we can write it is greater than 1 plus 1 upon 1 raised to p means I start with this 1 it is 1 upon 2 raised to p, 1 upon 3 raised to p, etc. Now it is greater than 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 and so on. Now it is greater than 1 plus 1 by 2 plus 1 by 2 plus 1 by 2 or 1 upon n raised to p is greater than, correct? 1 upon n raised to p is greater than this. It is greater than, what about 1 by 3? 1 by 3 is less than 1 by 2, correct? Less than 1 by 2. This step I am correct here. 1 upon n raised to p is greater than this, therefore it is greater than 1 plus 1 by 2, 1 by 3, etc. Yes, it is greater than, or what happened here? 1 by 3, it is less than 1 by 2, correct? Less than 1 by 4 and so on. What is the previous case? It is greater than 1 plus 1 by 2, 1 by 2 and so on. Correct? 1 by 4, but it becomes less than 1 by 2. It is 1 plus 1 by 2, 1 by 3, 1 by 4. 1 plus 1 by 2, 1 by 2. Is it true here? 1 by 3 is greater than 1 by 2. Not true here. 1 by 4 is greater than 1 by 2 is not true. So, in this step we cannot write. It is sigma 1 upon n raised to p is 1 plus 1 by 2 plus 1 by 3 plus it is greater than 1 plus 1 by 2, 1 by 3, 1 by 4 and so on. Now, can we apply the first case here? First case. What is the first? Second case. Now we take like this. We arrange the groups terms like this. It is greater than 1 plus 1 by 2, etc. Now we proceed as in the case 2. How do you apply case 2 now? Case 2 can be applied like this. What is the case 2? Case 2 is like this. We group the terms like this. It is equal to 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5 plus 1 by 6 plus 1 by 7 plus 1 by 8, etc. See, now exactly it is same as the first case, second case. So I think this you all have followed. 1 upon n raised to p is greater than 1 upon n for all n 2, 3, 4, etc. Therefore, I have taken 1 plus greater than 1 by 2, 1 by 3, 1 by 4, etc. Now, since it is a positive term series, the arrangement of the terms of the grouping of the terms of the series is important. How do you group the series here? 1 plus 1 by 2, 1 by 3 plus 1 by 4, and so on. So it is 1 plus 1 by 2. Again, this important. What is that? 1 by 3 is greater than 1 by 4. Correct? 1 by 3 is greater than 1 by 4. 4 is greater than 3. 1 by 4 is less than 1 by 3. Or 1 by 3 is greater than 1 by 4. Therefore, I write it is greater than. In this step, I carry greater than 1 plus 1 by 2 plus 1 by 2, 1 by 4 plus 1 by 4. Because 1 by 3 is greater than 1 by 3 is greater than 1 by 4. 1 by 3 is greater than 1 by 4. Therefore, greater than 1 by 4 plus 1 by 4. Plus 1 by 5 is greater than 1 by 8. 1 by 6 is greater than 1 by 8. 1 by 7 is greater than 1 by 8. Therefore, we write 1 by 8 plus 1 by 8 plus 1 by 8 plus 1 by 8 plus so on. Therefore, it is greater than 1 plus 1 by 2 plus 1 by 2 plus 1 by 2, because it is 4 by 8 means 1 by 2. Now the next rest of the thing is exactly the same case as second one. 1 by 3 plus 1 by 4 and so on. Now we arrange the terms of the series like this. Now it reduces to exactly the case 2 now. What we have done in case 2? It is sigma 1 upon n raised to p when p less than 1 here, third case, it is like this, it is greater than this. Now consider the right hand side series. What is the right hand side series? We take for right hand side series sequence of partial sum Sn is 1 plus 1 by 2 plus 1 by 2 plus etc. 1 by 2 n times. Therefore, it is 1 plus n minus 1 by 2 is 1. It is therefore n plus 1 by 2, and Sn tends to infinity as n tends to infinity. So Sn diverges. Right hand side series diverges. Sigma 1 upon n raised to diverges when p less than 1. P less than 1. These are the three different cases. You go through the video again and try to understand the proof of this. From examination point of view, proof is also important. Now how to apply this test? What is that? P series test. I take this problem. Discuss the convergence of sigma n is equal to 2 to infinity 1 upon n square log n. 1 upon n square log n. Now here we know that log n is greater than 1 for all n greater than or equal to 3. N means ln, it is base is e. Therefore log n is greater than 1 for all n greater than or equal to 3. 1 upon log n is less than 1 for all n greater than or equal to 3. Less than 1. Now 1 upon n square log n, 1 upon n square into log n is less than 1 upon n square for all n greater than or equal to 3. Greater than or equal to 3. Therefore, here 1 upon n square log n is less than 1 upon n. 1 upon n square log n is less than 1 upon n, of course, for all n greater than or equal to 3. Now therefore series 1 upon n square log n is less than sigma 1 upon n square, n is equal to 2 to infinity here. Now we can take n is equal to 3 to infinity. See, in case of infinite series, we can leave some terms or we can add some terms, and it doesn't affect the convergence or divergence, because series means it involves infinite number of terms. From that infinite number of terms, if we leave some terms or if we add some finite terms, the convergence or divergence is unaltered. Therefore, instead of 2 to infinity, we can take 3 to infinity. Sigma 3 to infinity is less than sigma 1 upon n square. Now see the right hand side series. What is this? Sigma 1 upon n raised to p form. 1 upon n raised to p. Now what is p here? P is 2. That value of p is important. It is greater than 1. Therefore right hand side series converges. Why it converges? Because sigma 1 upon n raised to p, see the previous theorem, that is called auxiliary series or p series. What is that p series? Sigma 1 upon n raised to p. It converges if p greater than 1. Here p is greater than 1, therefore sigma 1 upon n square converges. Therefore by comparison test, see now the comparison test plays very important role. This comparison test and p series test. Of course, one more comparison test. Totally there are 3 comparison tests. One is over. What is that comparison test? If an less than or equal to bn for all n greater than k, and sigma bn, the right hand side, sigma bn converges, then sigma an also converges. Now we can apply that test here. Right hand side series sigma bn, it is converges. Therefore left hand side series also converges. Therefore sigma 1 upon n square, n is equal to 3 to infinity, n square log n converges. Therefore 2 to infinity also converges. So this is how we can apply that comparison test and p series test. This p series test is very important. It plays important role in the problems. So far we have discussed first comparison test and p series test. I think all have followed the proof of p series test. You go through the video again and again, you will get the proof. Next is, it is called comparison test 2. I take that comparison test 2 and then you have to apply that comparison test 2 and p series test 2 many problems. We can solve many problems using that, and I consider that in the next period. Okay, thank you.